Hello everybody and welcome back to the Farmer Western Place, where as you can see I have a lot of windows open. Holy moly. Hold, let's right. What's going on? Okay, yeah. I was doing a little bit of cleanup off camera. So, we have our oh, you did get the first. Good job, Strace. Also, how you doing? I did some cleaning up of the maze solving code. It's not. I mean, it's a bit cleaner. And what I did is I also did some optimization. Like we have this feature we unlocked a while ago, but never really looked at because it wasn't time to get it. See what I? Okay, fine. We unlocked this timing function to get ticks, and this basically allowed me to do some simple benchmarking and to run 300 max size mazes. The starting point was 1391 seconds. So around 1,400. After I went and did a bunch of optimizations here, I got that down to 1,200. So about 1/7 performance increase. I don't actually know how much that is. I mean, we can find out. How much is 1/7? Stop it, you. 0. Yeah, so we got around a 14% performance buff on the maze solving. The most interesting thing I did to get more performance was actually this. So we used the position as a subkey on the hash map to prevent hash collisions. Instead, I chose to use a random value. So I guess this takes 1 operation, 2 operation, 3 operations, plus the indexing, so it's like 5 operations to compute this. I think that's how that works. And this random here is just 1 operation. And it removes any direction bias. So this was actually like maybe the biggest optimization. What else did I do? Yeah, I cleaned up the code to extract all the node functions. So the node is now a list instead of a dictionary. Because the index into the list is slightly cheaper because you don't need to compute the hash based on the size of the key. And that also did save a little bit, not as much as I thought it would, because I guess these weren't as frequently accessed as I thought they were, because I did a bunch of optimization work prior to that to reduce the number of accesses by keeping stuff around in variables instead of rechecking. I also changed the logic here, so we don't add a node back into the queue if the cost is less than the old cost, because our heuristic function for A star is both admissible and continuous. That means it's enough to check if the node has been visited. So this also saved a chunk of time. I've been so busy at work, I come home and do more work. Exactly. I'm a workaholic. Now this, I get to do work with you guys, and that makes it all so much better. Why is this a curse of tech workers everywhere? We become tech workers because we're cursed, strays. That's how this works. Anyway, TLDR, figured out benchmarking, and our mace is now faster. I also split this utils file into crop and motion utils, and I did some cleanup of the various motion commands. So we're gonna actually start today by getting rid of all references to utils, I think. So let's do surfer from utils here. Let's change this to motion utils and crop utils. Actually, let's just copy paste this all across. We can do more betterer imports later. But now I just want to get rid of that file. Yeah. Now, I would like to run our main for a little while so that we see if we have forgotten anything. Yep. Modian. Really? Really, Emily? The title with this name does not exist. Oh, did I? This is a great start in it. Yep. All right, let's give that a go. Let's not give that a go. I meant now. Okay, so we don't have the for each function moved over yet. Grab that. Uh-huh. Why do I have two of these? I think one of them was... I was testing which one was faster. It was probably number 1, because I have no references left to number 2. Error type when import. Wouldn't be the first time. Okay. Will you run? Okay. That think means we can get rid of utils. I just wanna give it a little bit of time to run a couple of cycles so as we see that we're not missing anything. Have these benchmarking files separately here. So, is this function ever used? No, I think we can just straight up nuke this. Could it be used? Didn't we figure out a better way of During this iteration. Oh yeah, I cleaned up the move actually command. I actually cleaned it up. I'll be here all week. I won't, but it's the sentiment that counts. So yeah, I got that a bunch cleaner here. Reduce some code. Does this need to be cleaned up? I don't actually think that it's that bad. I mean, this is a little bit annoying, actually. Maybe this is just... Hold on, I have an idea. Vertical direction is north. Okay, that means we're always heading in the vertical direction. And the vertical direction is the opposite direction of the current vertical direction. Easy. Easy peasy lemon squeezy. And why is this here? Python, why are you the way you are? Oh, that's not a file we're running, idiot. Oh, that seems to still be working. There's a bunch of instructions. All right. I think that's good for the cleanup for now. The crop utils is just basically copied over from the utils file. It does need a little bit of spit polish, but that can wait. Let's have a look in our unlocks here. Right, we did the cactus. We did the dino. The hat is fancy. The new tech that we can unlock is leaderboard. I feel like that's maybe the last thing we do. Enter the leaderboard for the fastest time. Oh, for the various different crops. I see. Interesting. So I guess our options are 100 million dino bones. That's not happening for a while. So it's either the mega farm to spawn more drones or polyculture. I feel like we probably want to figure out polyculture before we do the mega drone. So let's start here. You may have already noticed that sometimes plants yield more when planted together. Can we move a bit away from the sound? Thank you. Do they? Grass, bushes, trees, and carrots. So, yeah, the things that do not have special planting patterns yield more when they have the right plant companion. Companion preference is different for each individual plant and cannot be predicted. Really? each individual plant, not species, plant. What? Oh, you're solving mazes, okay. I was like, what the heck is that sound? Fortunately, the companion preference of the plant under the drone can be measured using get companion. It returns a tuple where the first element is the type of plant it wants as its companion, and the second element is the position where it wants its companion. Oh, so it's an XY tuple. Okay. For example, if you plant a bush and call get companion, it will return something like a carrot on a specific position. I initially thought this would be a direction, but it clearly says position. Because it's companion, I assumed it would be like in a specific direction. This means that this bush would like to have carrots at the position 3-5. So if you plant carrots at 3-5 and then harvest the bush, it will yield more wood. How much more? The growth stage of the carrot doesn't matter. Okay. A plant's companion preference can be either grass, bush, tree, or carrot. Each plant chooses this randomly, but will always choose a different plant than itself. Okay. The position can also be any position within 3 moves of the plant, except the position of the plant itself. So 3 moves is... it's a diamond around the plant. Okay. If there is no plant under the drone that has a companion preference, get companion will return none. Okay, so we get 5 times more yield by planting this way. Okay. Okay, so this seems fairly straightforward. If we want to make use of polyculture, we plant something, we read its companion, go to that position. If there's something there, we harvest it and replant and keep going like that until some criteria, at which point we harvest everything. Is this really gonna be more efficient than just planting the full field? Like, what will this tell us to plant something somewhere where there already is a plant? I mean, I guess there's only one way to find out, right? Look at our guy go. It will tell us to plant where there already is stuff. Okay. I feel like he's faster, is he not? Like, I made the entire time to solve 300 mazes 14% faster. And because a decent chunk of that is the travel time, the actual computational time got proportionally much faster. So maybe like 30-40%. Dude, look at him go! Also, this maze is a lot smaller than the one I was benchmarking on. Look at him zoomy, zoomy, zoomy. Okay. Your code triggered a warning. Oh, did I leave that hacking debug print in there? I did. I don't really want to remove that while this guy is solving all the mazes that we have invested in right now. So we'll let him complete. And then we will, I guess, do some experimentation. So we'll start by bringing in all of the utils. We will, I guess we'll clear for now, and then we'll plant, let's plant a carrot. A bush, a bush. We'll get companion. This will be entity. And I wonder if this will work. After this, we will move to position and plant entity. Yeah, so maybe we formulate this like this. And then we'll start with an infinite loop here. Okay, now we can fix the debug prints. Now let's remove all the different time measuring things I had in here. Okay, that should do that. Now back to this thing. We have maybe harvest replant the entity we have selected. I will get its position and we'll go there and then repeat. I just want to see where this actually gets us. They have each other? Interesting. Okay. Huh. Okay. I was not anticipating the loop pattern. How do we handle this? Like, this is clearly suboptimal. Hey, Kermi. Welcome in. Hmm. So our current implementation is clearly worse than just planting the entire field. So I feel like we are going to need some kind of memory and decision tree to figure out when we should be harvesting and when we should be replanting. Just maybe harvest, replant, return. Okay, so let's return true if we got something, and false otherwise. And how does that help me? We can skip the current one and go plant somewhere else. Where is somewhere else? Well, because we're scattering stuff all over the map with this planting strategy. It could be any hecking where. Let's try something really stupid. If we cannot do the thing, then we will move direction to vector. No. We will move in. In a random direction. And then we will try to replant. Oh, this is gonna be so stupid. We need a square bracket Reno. And a colon, you know. I mean, statistically speaking, right? It's likely to go somewhere where it can harvest. This is the most chaotic farmer I have ever seen. This is so unsatisfying. I feel like I'm gonna get demonetized on YouTube. And I'm not even monetized. How